So we'll begin to tackle here then with the bucket sort. So for the bucket sort, that is dealing with the sorting algorithm that works by distributing the elements of the array into several smaller subarrays called the buckets. So these buckets are formed by uniformly distributing the elements. Once the elements are divided into buckets, they can be sorted using any other algorithm. So of course, here then create a buckets, distribute elements into the buckets, sort each bucket, then concatenate the sorted other bucket as well. So for that one, basically, for creating the bucket, you have to divide the range of the data into unequal intervals, creating n buckets. Each bucket will hold a sub-range of the values from the array. Then distribute elements into the bucket. Place each element from the input array into the appropriate bucket based on its value. The exact bucket each element goes into is determined by the value range each bucket represents. So for example, 0 to 10, 11 to 20, something like that. So for afterwards, you have to sort each bucket using any other sorting algorithm technique. This can be done using any sorting algorithm such as insertion, selection, merge, or quick sort. Depend on the given in your examination. There will be a specific instruction that you have to follow. What will be the sorting algorithm that you have to definitely do, depending on the size of the bucket and efficiency considerations. You have to concatenate the sorted buckets. Once all the buckets are sorted, you have to concatenate everything, the sorted elements from all the buckets to form the final sorted array. So that's the only thing that you will need to do. Time complexity here, if the best and average time complexity is definitely O of n, then plus k, where if the elements are uniformly distributed, the O n divided k squared term becomes much smaller and the time complexity becomes closer to linear complexity. So that means to say the time complexity of bucket sort depends on the n, which is the number of elements in the input array, k, the number of buckets used, and m, the number of elements per bucket, or the average number of elements in each bucket. Because there is a lot of cases inside in your bucket actually. And afterwards, for this one, since as we do have in the steps of that bucket, we have to distribute the elements into the bucket that is requiring linear time complexity. Then for sorting each bucket, the time complexity of that one, the sorting elements within each bucket, depending on the sorting algorithm used. If you are using insertion, if you're using this kind of algorithm, it does actually follow in specific sorting algorithm what will be the specific limit complexities for that. So commonly, the time complexity for sorting one bucket is big O of m squared for each bucket. So if the elements are uniformly distributed among the k buckets, the average number of elements in each bucket is definitely n divided by k. The sorting each bucket would thus take their own notation of n divided by k then squared. Time of each bucket if we use it could be insertion sort. Then after concatenation, the sorted bucket into the final array takes linear time. So the best average case definitely if the element are uniformly distributed, that will be the linear complexities, which the term becomes much smaller. Time complexity comes closer to the linear time. For the worst case time complexity, if all the elements end up in the same bucket, which can happen in the worst case, if that input array is not uniformly distributed, the bucket sort would degrade to the time complexity of the sorting algorithm used in the bucket. So that means to say there is in quadratic time if you're using insertion sort. Next will be the space complexity, which will be I'm sorry, O n plus k, which the linear for storing the input array and O of k for the buckets. So that's the space complexity. So the space complexity is definitely O of n plus k because due to the space needed for the buckets and the input size of the array. Now that's the end of our definitions. Thank you.